So this is the first video for the gas law unit. Please make sure that you have already completed the organizer titled Introduction to Gas Properties. It's your page 703 in the binder. You should have been able to look up kinetic molecular theory, learn a little bit about how temperature is measured for gases, how pressure is measured for gases, done some practice problems with those conversions. So only after you do that should you watch this video. So first thing I want to do is just make sure you've got the ideas of the kinetic molecular theory down. So the first idea that the kinetic molecular theory supports is the idea that gas molecules are really far apart. So we talk about them as being mostly empty space, which means there are no IMFAs between gas molecules, and that's why they fill the container that they're in. Second idea you should get from the kinetic molecular theory is that we consider gases to have elastic collisions. That means they don't lose energy on impact. So whatever energy they have going into the collision, that's what they walk away from the collision with. Third idea is basically about temperature. And we found that the average kinetic energy, the energy of motion, is what temperature is. And for gases, the average kinetic energy, the temperature, is actually proportional to the motion of just the Kelvin scale. And the reason for that is Kelvin scales don't have negative temperatures. So you don't have to deal with a negative number at all in your calculations, because it needs to be a direct correlation between motion and temperature. What does a negative temperature mean? That doesn't make sense. The molecules aren't moving backwards, they're just moving. So a negative temperature doesn't make sense, so we use Kelvin for any sort of calculation involving gases. And then the final idea is the idea that pressure is exerted by a gas as a result of collisions. So either between molecules or between molecules and the walls of their container, that's how we get pressure. So those are the four ideas of the kinetic molecular theory that you should have learned. Then we need to go on and talk about temperature. You did a little bit of investigation for temperature. So temperature, what's the conversion between Celsius and Kelvin? You should add 273 to your Celsius temperature to equal your Kelvin temperature. And as a result, 0 Kelvin should wind up being negative 273. I know it's negative 273.15. We're not going to worry about the 0.15. So that's your equation for that. So then you had to do some calculations. So double check your answers. Make sure that the answers that you got for your temperature scale or your temperature conversions are what are shown here. So 400 degrees Kelvin is equal to 127 Celsius. Negative 95 degrees Celsius is equal to 178 Kelvin. 200 Celsius is equal to 473 Kelvin. 21 Kelvin is actually negative 252 Celsius. 150 Kelvin is negative 123 Celsius. And finally, 500 Celsius is 773 Kelvin. So make sure those are okay. All right, and then the rest of the organizer goes on to talk about pressure. And the one idea for pressure is making sure you can do the conversions between all of those units. So once again, here is the set of answers for those conversions. So you should have found that 1 atm is equal to 760 millimeters of mercury, or 101.3 kilopascals, or 14.7 psi, and psi is pounds per square inch. When you found the definition of pressure, you probably found that pressure was force per area. PSI is really a true example of force per area. Pound is a force, and obviously area is in the inch squared. And then also you can see the answers to the conversions. Just do a little dimensional analysis problem to get these, and double check what you have there. 1900, 1654, 36.3, 46.7, 0.97, and finally 2.4 are your answers. All right, so with those ideas, in order for us to transition into the first activity that you're doing, we need to talk about variables that you're going to. And so for gases, there are 4 variables that influence the properties of gases. First is temperature. As you know, we just learned temperature is how fast the molecules move. And so we can express those in Kelvin or Celsius, but in order to do any math, temperature must be Kelvin. Please note that temperature gets the variable capital T. T is not a unit, T is a variable. So those are what we're going to put into any of our equations that we use to solve for gas laws quantitatively. You would never say the temperature is 25 T, you would say it's 25 Celsius, but T is the variable. Pressure is one of the other things that we learned about. Pressure is P, and remember that it is how many collisions you have, how often molecules are colliding, and you've got the units that you just did some practice conversions with, ATMs, millimeters of mercury, kilopascals, and PSI. Finally, you have, I shouldn't say finally, you have 2 more. Volume, given the abbreviation V, capital V. Volume is really the space between particles, so that the particles are closer together. Obviously, the volume is going to be smaller. We express those 2 as liters or milliliters typically. And then finally, you've got the number of particles, which is what moles identifies. You've got the variable for moles is N. So again, N is a variable, it's not a unit. So you can't say that I have 2.5 N of oxygen. You say you have 2.5 moles of oxygen. So we are going to take those 4 ideas and use them in a gas exploration. What you're going to need to do is think which variables are being held constant and which variables are going to be moving. So, for example, if you are going to investigate the relationship between pressure and volume, you have to keep constant temperature and moles. That means you can change the volume of the container, you can see what happens to the number of collisions, but in order to do that, the speed of the molecules have to be constant, temperature has to be constant, and you can't change the number of molecules. So this gas exploration is going to let you explore the 6 relationships between these 4 variables that are going to exist. So have fun with the exploration and continue on there. This is now the end of your first video.